Parametric form. The tangents and normals, so the formula's there. Xy equals c squared at the point CP, comma c over p. So that's your parametric form of your rectangular hyperbola, specifically. Remember your parametric form of your hyperbola is x value is a of tan theta and b value is a of sec, sorry, y value of b of sec theta for your general hyperbola. When you have specifically rectangular hyperbola, you have x equals cp and y equals c over p. Right, so the equations, normals and the tangents are given there. Right, so we need to show that there are generally four normals that we can draw from an external point to a hyperbola xy equals c squared. Right, so x is cp and y is cp to the negative 1. So just rewrite the fraction to make it more straightforward to differentiate. So dx over dp. Okay, so we can't differentiate with respect to c because c is our constant. It's just representing a number, so we have to do it with the variable, which is p. Differentiate x with respect to p, we get c. And differentiate y with respect to p, give me negative cp to the minus 2. And use your index clause. dy dx, give me dy over dp times dp over dx. So setting up our chain rule. Okay, so dy dp is there. The negative c over p squared, so just write it back as a fraction. Because I'm observing, I'm going to be multiplying by a fraction. And then the reciprocal of dx over dp. Right. With a gradient at any point on the curve, you can be represented by that, and depending on the value of p. So, normals. So we need perpendicular. Okay, reciprocal chain sign. Y take away c over p, give me p squared x minus cp, using your parametric form from the top. Your point in parametric form, sorry. Right, so span the whole thing out. So y take away c over p, okay, p squared x minus cp cubed. And I'm going to remove the denominator by multiplying everything by p. So py take away c, and p cubed x take away cp to the power of 4. Alright, so just to remove bias, select external point is capital X, capital Y, just some arbitrary point. Picking some external point. I could have called it x1, y1, whatever. Just name it capital. Alright, so I'm going to get it into polynomial form from p. So 0 is going to be cp to the power of 4. So everything's going to be moved over to the left hand side in decreasing powers of x. P, sorry, minus x p cubed don't have a p squared. Nope, okay. So this should be capital X because I'm substituting my point, x, y, capital Y for my little x, little y, plus capital Y, p, take away c. So now I've got a polynomial in terms of p. Okay, and this is our quartic polynomial, so that means there can be generally 4 roots for the values for p. Okay, so quartic polynomial. okay, in terms of P. Okay, so it implies that generally, not always, okay, because it depends on double roots. So double root means there's going to be the same point on the hyperbola. Triple root is going to be 3 lots of the same point. Generally, there are 4 values of P. Okay, so for different values, okay, so generally speaking, we need more information on the question itself to be able to do more. Okay, so therefore, generally, there are 4 normals to the hyperbola. Right, so this is C in your notes. Okay, so just change the order, doesn't really matter, in your notes. C. Because I want to do this one before the other one, depending on the time, and I want to be able to get to the last question as well. Right, so the normal at P, make the x-axis at M, and the tangent at P, make the y-axis at N. We need to prove that the locus of the midpoint of the intercepts of the axis for the normal and tangent respectively, as the point P varies, is going to be given by that equation there. Right, these sort of questions, what's the first thing you're going to do? Good. You can't do anything else, start a sketch, okay? Alright, so draw a general rectangular hyperbola. Right, so we got the normal at a point P. Alright, so anywhere on there, just going to put it about there. Right, draw the normal. Meets the x-axis at M. And the tangent at P. Going to meet the y-axis at N. So we've got the interval, which is the midpoint R on there. So the block at the midpoint R of Mn as the point P varies. We will need to come up with that equation somehow. Alright, so we can first by finding the intercepts of the axis. Okay, so let's go to tangent first. The tangent at P, just going to write it straight down. So x plus p squared y is 2cp. So that's from the parametric result from the previous page. Okay, so we've just done deriving it, or differentiated with substituting, etc., etc. Right, so we know that it crosses the tangent, crosses the y-axis, so x equals 0. P squared y is going to be 2cp. Y is going to be 2c on P. Right, normal. Right, so from the previous page, the equation is p cubed x, take away py, equal to c outside of p to the power of 4, take away 1. Alright, so they're just recalling the formulas from the previous page. Alright, so we know that this crosses the x-axis, so the y value must be 0. So y is 0. X is going to be c outside of p the power of 4 take away 1 over p cubed. Right, so now we've got the x and y values for both m and n. We can now calculate the midpoint r. Really, because one of them is going to be, when you calculate the midpoint, you're going to add 0 and then you're going to divide by 2. So all we really need to do is write midpoint in, is divide both of these variables by 2. Okay, so midpoint of capital N, you're going to have the variable r. Right, so the x value is going to be that plus 0, all divided by 2. So yeah, so I have p to the power of 4 take away 1 over 2p cubed. And the y value is going to be 2c over p plus 0 for the other y value, and then we're going to divide it by 2. So c over p. Right, so for the point R, x value is going to be c, p to the power of 4 take away 1 over 2p cubed, and the y value is going to be c over p. So we need to find the locus, we need to eliminate the parameters. Which variable is the parameter? P. Okay, because c is a constant, so we need to eliminate p somehow. So looking at the equation on the right, I can very easily write p as subject on the one on the right and then substitute that one on the left. Okay, so p can be c over y. 1. I'm going to put it into the first equation. C 4 over y to 4 take away 1 2 b cubed over y cubed. Right, so now it's just a matter of tidying up. Right, so c to the power of 4 take away y to the power of 4 all over y to the power of 4 times y cubed over 2c cubed. There's a couple of lines working there. Right, so I put this away of common denominator and then I multiply by the reciprocal. And now I can start doing some cancelling. This is a common factor. The y to the power of 3 will cancel with 3 of the y to the power of 4s, and the c will cancel with 1 of the cubes there. So on the denominator I have y, 2 and c squared. I'm going to bring it up to this side, multiply by x, 2c squared xy, moving everything on the denominator back up here. And we've just got that numerator left. C to the power of 4 take away y to the power of 4. As required. Right, any question? Right, short enough time. So the locus of the foot N of the perpendicular ON drawn from the origin to the tangent to the curve x equals c squared at the point P. Right, so in your notes this is B. Okay, so what this is really saying, that you pick point P, draw the tangent, and then the foot is from the origin perpendicular to that tangent. Okay? minus P O N intersection of them. Right, so what is the gradient of Pn? What's an expression for the gradient of Pn, I should say. It's already done it today. We've done it, so for sure we've done it. Alright, so we've already done it right at the start when I derived it. Alright, so we'll just take our word for it now. Okay, it's the gradient, you will need that later on. Alright, and the tangent. So x plus p squared y is 2 Cp. Okay, so we're calling that formula. It's all in parametric form, by the way, because the point's given to me in parametrics. Right. So, the trick here, we're going to square both sides. Because I want to be able to use this gradient, and I will in a moment. So, x squared plus 2 p squared xy plus p to the 4 y squared will be 4c squared p squared. Right, so the reason why I've done that because I want p squared in my expression. And to use that, we know the facts, so ON is perpendicular to PN. Okay, so that means the gradient of ON is what? Okay, so reciprocal, change sign. So the gradient is p squared. Okay, so if we let the point n is some variable, so again, call it capital X, capital Y. What's the gradient of ON given the coordinates? So this is 0, 0, and this is capital X, capital Y. What's the gradient? Integral ON with respect to what I've got in the diagram.
X, Y. X over Y.
Other way around.
Y over X.
But Y take away 0 over X take away 0. Okay? It's capital Y over capital X. And that means my p squared equals capital Y over capital X. So I'm eliminating parameter by substituting my point. So every time there's little x, little y, I'm going to replace it with capital X, capital Y. And p squared is going to be replaced by y over x. So x squared plus 2 p squared is 2y over x times x y, capital X, capital Y. So we're substituting our point into the equation of the tangent, plus p to the power of 4, which is p squared or squared. So that becomes y squared on x squared times capital Y squared 4 c squared y on x. Right, so I have eliminated the parameter. Y, I've expanded it. okay, because I wanted a p squared to deal with here, and even powers of p squared. Alright, so x cancels there. Alright, so now I'm going to multiply the whole expression by capital X squared to remove the denominators. So x to the power of 4 plus 2 capital X squared capital Y squared plus y to the power of 4 is going to be 4c squared x y, capital X, capital Y. Right, can you guys see a way how to simplify the left hand side?
Factor out x and y.
Well, the y here still.
Oh,
What does it almost look like?
I have x squared.
So x squared plus capital Y squared, all squared. Yep. Equal to 4c squared capital X capital Y. Alright, and we're done, pretty much done. Can't do any much further. So therefore, locus of capital R is going to be x squared plus, so we can go back to our lowercase, because now we're just showing the path, not just a point. All squared is going to be 4c squared xy. Question?